Good afternoon, everyone. Today we start the chapter number 5. In the last lecture, we discussed here the numerical about the braking systems, and this in the chapter number 4, control system. Is steering system and control system is important for some solving or an understanding about their some the control system in vehicle engineering or automobile engineering. But when we discussed about in the last previous lectures is here about the steering, also we control to avoid the accidents into this road, also we control with the help of some braking to avoid the accidents and then unwanted circumstances. That's why we move further for also some control the vehicle with the help of some the suspension system is here. So that's why the chapter number 5 is here, this suspension system. So suspension system is nothing but that this in the PDF. I will share this PDF in your this Google Classroom here. So the suspension system is provide this cushioning the effect, is a soft effect to the vehicle against the road surface by giving the minimum up and down movement by this body and chassis. So when we restore or resist the shocks, so whatever is dumped or into this any bump values, this dumping and bumping of their wheels on the road and in some rough road is jerks on body of their passengers and then drivers. So it is harmful to this all body, just like the back and then the foot and then head or neck is here. So avoid these disturbances, to avoid this painful in our body, we taken as a suspension system, and this suspension system provide the cushioning effects, is some the rest effects to the vehicles on this road roughness. So minimum up and downs momentum of the body and chassis. So this main is here the function of this the suspension system is here, it provide the cushioning to the vehicle against to the shocks due to this road roughness by giving a minimum up and down momentum to the frame. Second is here to support the wheel of the vehicle called as spring weight, and this spring weight is also the addition of the total weight of the vehicles plus the weight of the spring is nothing but this spring weight is to third function of that the suspension system is there, it always maintain the grip between tire and road. The fourth function of the suspension system is here, it's allow the vehicles to take turn with minimum rolling, also it is related to the steering system is here. Then point number 5 for that, it also hold the wheel in alignments. So when these think about there, this toe in toe out and caster and camber terminology is considered into these wheel alignments to also depends upon their the suspension systems. Then the function about their suspension system is point number 6 is takes the driving and braking torque of their vehicles. The point number 7 is provide the comfort to occupants. So that's why the function of the suspension system is provide the cushioning, it support the weights of the vehicle, it always maintain the grip between tire and road, it allows the vehicle to take turn in minimum rollings, it hold the wheel in alignments, it take the driving and braking torque of the vehicles, and it provides the comfort to occupants. So this is the 5 6 7 function of the suspension systems with the help of some the provide the cushioning effect. Then we move further for the sprung and unsprung weight. This is some theoretical part or the terminology into this suspension systems here. The first point is here the sprung weight. So what is sprung weight? It is a weight of the suspension systems and weight of the vehicle which supported on their suspension system or the spring. So this sprung weight is equal to the weight of the body and chassis plus weight of the suspension spring. And second point is here unprung weight. This unprung weight is here, it is a weight which is not supported by the suspensions, it is that only is unsprung is here, is defined as here, it is a weight which is not supported by the suspension spring, that is the weight of the wheel, axle, differential, tire, steering, knuckle, brake, etc. So the unsprung weight is equal to total weight of the vehicles minus sprung weight. The sprung weight should be as low as possible to minimize the vibrations. The sprung weight should be as low as possible to minimize the vibrations. So this the sprung weight is also some terminology takes place into the suspension system. So this main to sprung weight and unsprung weight is important for some understanding suspension system. The next terminology is here this brake dip and wind dips. So what is a brake dip? When the brake is applied to the moving vehicles, the nose of the vehicle tends down, lower down or deep down. This the compression of the front suspension systems. This the phenomena is called as brake dip. And wind dip is there when vehicles start moving. A vehicle torque is applied which is tends to lift the front of the vehicle. This is a suspension spring is affected. So this phenomena is called as the wind up. So next is the suspension spring. This various type of the suspension springs is used in the suspension system is there. I'll call them when the suspension load is applied on the screen. It start the vibrating and then vibrations dub down with this passage of the time. So the suspension spring is here. Two various type of the springs is absorb or suddenly apply the load into this the brake dip or wind up or any kind of the dump and bump on their the wheels. This is oscillating too much. That's why we absorb the shocks and to convert into the cushioning effects. That's why the suspension spring is required. Next is here this load is required per unit deflection or the spring rate. It is defined as the suspension or the heart of the spring. The load required to compress a spring through a 1 unit of a distance is called as spring rate. More the load required and more is toughness of the spring. The linear rate R has a strong uniform cross sections wired will compress uniform. So the spring rate is nothing but this load required per unit deflection. So whatever we applied on this load of the chassis or this the passengers or the vehicles is how much the deflected per unit is here is nothing but is spring rate. And this spring has some different types. Is suspension spring is first as a lift spring, coil spring, torsion bar and air spring. So lift spring is here. The spring is consist of long or flat flexible or each plate has a nothing but the lifts. This lift spring is semi-elliptical, full semi-elliptical, cortical effectible or transfer effectible. So first is semi-elliptical shown as in the diagram. Is lift spring is fitted on the rear axle. Is consist as the main lift spring is connected to this each eyes. These are the eyes, each spring eyes. This spring eyes is connected to the main spring and with lift up that this U type lift spring is connected with some U bolt or this the clamp. And when this clamp is moving from semi-elliptical lift spring is nothing but that the smaller leaves are clamped together with main lift. There is a U bolt which is fit the spring on the axle. This the front end of this spring is mounted on the rigid support with left help of pin. The rear end is mounted on the shackle is pivoted which is given as a flexible connections. The rubber bush or the phosphor bronze is used for the lift spring iron. Okay, so this whatever we are using this semi-elliptical lift spring is mostly used the rubber bush or phosphorus bronze bush used for their these lift eyes. Next is your full elliptical link. This is a totally full elliptical spring. Is images shown as here. For this two semi-elliptical lift spring are connected together in such a way that one is fitted to the inverted positions. So it is helpful for avoid the shocks absorber and convert into the cushioning effect for these heavy vehicles, right? Then quarter elliptical lift spring, it is nothing but that is high semi elliptical, it is taken in the quarterly is some vertical and then horizontal are intersect each other with the help of some frame chamber. The transfer lead spring is also is used with some upper side of the lead spring is connected and the lower side is some front axle we can apply here. So this is the four type of the lead spring. This first is here nothing but that the semi elliptical lead spring, full elliptical lead spring or the quarter elliptical lead spring is here. And this quarter elliptical lead spring we can apply some transfer elliptical lead spring. So next is here details of lead spring is here. The spring eyes. The spring eyes here in different shapes. This type of these different shapes. In this 1 to 5 has some different shapes. This leaf end, which is a bending moment charged from 0 to neutral axis at there to the maximum surface. This is nothing but this a leaf end. Third point is here the leaf section. This slightly concavity is provided to the long side of the spring is conductivity concavity provide the space between the leaf spring for their the lubrications, and conactivity is the difference between the thickness of the center at this end and varies from 0.10 mm up to this 10 mm for various size of the spring is here. The shackle with rubber and rubber pad bushings is the image shown in front of here. The shackle link is here and this shackle link is connected to the rubber bushings for purpose. The next is here some slide block. This slide block also used for those two metallic concentric tubes has the field under pressure between two tubes and this thickness varies from 1.25 mm to 5 mm. This central portion of this inner tube is enlarged and end of their outer tube are flanged. This is a done take in a lateral load, and the advantages of this slide block is that our tube can turn up to the 60 degree with respect to each other. This torsional load is applied here. Then pressure block. This pressure block is used a U type of the clips used to reduce the inactive spring material to minimum the portion of the leaf spring to reduce the shocks absorber and used for the leaf spring with the help of some dividing the load among their inactive surfaces. The ribs are used to provide it for rigidity. Interleaf frictions, then spring curves and interleaf inserters. These solenoids inserts the rubber inserts and lead inserts. So variable rate spring is here. For the coil spring can also used into this variable rate spring is by giving the variation in coil diameter and the Y diameter. So the next is here the coil spring. This coil spring is made up of the length of the spring steel rod which is in rounded in cross section by winding it in shapes of the coils. It show the construction of coil spring. Its end are made up of the flat so that it can be sit properly. Coil springs are used mainly in independent suspension systems. Along they can used in conventional suspension also. The advantages of the using coil spring in place of the leaf spring is here the stored in more energy per unit volume than leaf spring. It does not produce noise, does not have static noise. It has both bending and shear process. Next is here the some torsional bar. This torsional bar, one end of the torsional bar is fixed and with the frame so that its end of the cannot be rotated. Thus torsional bar end is fixed. So this wheel arm also rested on this bearing of this bar. It is helpful for which wheel comes in across on this bump. It rises it giving up the wheel arms. This upward momentum of the wheel arm causes twisting in this torsion bar. Thus, the energy is absorbed in the bar, which is released upwards, energy stored in per unit weight in torsion bar. Almost it is useful that is coil spring. So that's why the advantages of the torsion bar is high, lighter in weight. It occupies the less space than the leaf spring. However, it does not take driving and braking thrust. Also, it needs additional arrangement for this purpose. Also, separate damping device is also needed. So next is spring about that is the air spring. The air spring is rubber bag filled with the compressed air. This is wall on this bag which is connected to the air compressor. This air compressor keep the air bag inflated, and this bag is placed in frame axle shown in this figure. It supports the weight of their frame. When the vehicle come back across the bumps, the airbag is compressed and air play role of the spring. As soon as the bag start to compress, the compressor supplier air to bag to minimum air level through a leveling valve. Thus, this between the frame is maintained into this the various bag on that. Okay. So what about there this air spring? The advantage of there the air spring is here. It maintain constant distance between frame and road surfaces. This is a low frequency spring which gives a comfortable ride. And then frequency remain constant. So the material also used for the spring is here first chrome vanadium steel, silico magnesium steel and carbon steel here. Okay, it is nothing but that the material for this. Though that's about totally that's about here some the basics information and then function, then the some different type of here this the suspension systems and then leaf spring, air spring, torsion bar, and these the air spring. So these are the some basic informations and detailing about their this first chapter about their suspension system. Okay, thank you.